let you know when I know, but I don't know. Okay, so we're just going to work with this first one up here to start thinking about some subtraction. So this is when we're going to look for our least common multiple of our denominators. So what is the least common multiple of 4 and 5? 20. So we're going to multiply each of these to get to that common denominator of 20. So I need to multiply my 4 by 5, but I can't just multiply by 5 on the bottom. I have to multiply by 1. So my 1/4 is going to turn into 5/20. We're unsimplifying the fraction. And then from that, we're going to subtract. Over here, we need to multiply my denominator by 4. But again, I can't just divide by 4. I need to multiply by 1. So we're going to have 4/20. What that means is we can take those numerators and subtract them. 5 minus 4 over 20. Well, 5 minus 4, that's just 1. So the difference between 1/4 and 1/5 is 1/20. And again, you can just cross out that bottom one because we're not doing it today because holy crazy morning, Batman. All right. Luckily, what we're doing today is almost identical to what we did yesterday. So this is a page we saw yesterday. We only worked with addition yesterday, which is this stuff up here. Today, we're going to work with subtraction. And literally, the only difference is that we subtract our numerators. We get to our common denominator. We put them together. We subtract. So there's going to be one extra step because of that subtraction. But it's really not super different. Okay, so this is 100% the exact same page we had yesterday. Like it was straight up copy and pasted. This is what we did yesterday where we got to our common denominator and added our numerators. Here we're going to get to our common denominator and subtract our numerators. That is all we're doing with this, okay? So we got to get to our common denominator, and then we simplify our numerator. So let's look at our first one. Yes, yeah, step in the hole. All right. So our first one here, we've got x minus 3 over 6x cubed minus x plus 3 over 6x cubed. So we already have common denominators with that 6x cubed. So I'm going to put these all into one fraction. We're going to combine them together. My denominator is 6x cubed. So I'm going to take this first piece and I'm going to write it down. We have our x minus 3. And then we need to subtract this whole second piece. I need to subtract x plus 3. So I'm going to put it in parentheses like this. Since we are subtracting, I need to take this whole chunk and subtract this whole chunk. So my extra step that we're going to have today is I'm going to need to distribute this minus sign whenever there's a plus after it, or whenever there's an operation after it. So what this really is x minus 3 minus x minus 3 over 6x cubed. Now we can come through and we can simplify. Our denominator is not going to change. Once we get to that common denominator, it doesn't really change. How many x's do we have left? 0. My x's cancel out. What is the number that we have left? -6. So we have no x's and we have -6. At this point, could we simplify this a little bit? Everything's being multiplied. What can simplify here? 6 and 6. So our answer is really going to be -1 over x cubed. So once we get to the end, we're going to look and see if we can simplify. Because sometimes when we've combined things together, we can simplify it in different ways we didn't see before. Most of the points, yeah. Because usually it'll say something like simplify the expression, which means I do need you to get all the way down to the end. But if we got here, we've done the hard part. And so usually something like this would be 4 or 5 points. And this getting to here would get you 4, maybe 4.5, depending on how complicated this side was. All right. Here's our next one. This one's kind of weird looking at it. So the first thing we need to do is to figure out what our denominator is going to be. We need our least common multiple of our two denominator pieces. So what is the least common multiple of 9 and 6? 18. And then we need to have each of those letters. I need a Y and I need a Z. So if I need this left-hand fraction to wind up with a denominator of 8z, of 18yz, excuse me, what do we need to multiply it by? 2 and z, the pieces that it's missing. Again, I can only multiply by 1, so I need to do 2z over 2z. How about the right-hand side? What's this one going to multiply by? 3 and y. So we just kind of go, what is missing from here to get to here? So we're going to wind up with our 18yz as our denominator. And we have 2z times 2x, giving us 4xz. And we're going to subtract 7y minus 3y, which gives me 21y squared. Can we simplify this any further? No. There's no GCFs on the top I can take out. 4 and 21 don't have any common factors except 1. They don't have any letters in common. So I know I can't put this into a factored form and simplify something. We can only simplify when it's got terms that are multiplied. So since these are subtracted, I can't simplify as it is. So that is what we can do on this one.
I have a question.
What's up?
What about the z's?
Since this one over here does not have a z, I can't take out a z as a common multiple. If I split this apart into two fractions, I could get out a z, but then we'd wind up right back up here. Since we were combining them together and not everybody has z's, I can't take out a z. Since this is subtraction here, I can't just cross out as it is. I'd have to put it in factored form to be able to do the crossy-outy thing. So let's look at another one. So this one's kind of bigger. We've got 2x plus 1 over x squared plus 2x minus 15. And we're going to subtract 7 over 5x minus 15. So So my first step needs to be to get this into factored form in all the denominators, because I don't know what pieces are missing if I don't know what pieces are there. So we need to put this into factored form first. So my numerator on the left is my 2x plus 1. There's no GCF there, nothing crazy. So then we're going to look at our denominator here, and we're going to factor this. So I'm going to use my x, a times c, 1 times negative 15 is negative 15, b is positive 2. What is a pair of numbers that multiplies to make negative 15 and adds to make positive 2? 5 and negative 3. So we have x plus 5, x minus 3. And we are subtracting from that the fraction on the right. I have my 7. And I'm going to look at my denominator here. Can I simplify this a little bit? Is there any factoring I can do here? What can we take out? A 5. So it's going to be 5 times x minus 3. I'm going to switch that blue to be a little bit darker. I feel like it's really pale. There we go. I feel like that's easier to read. So now we can look and figure out what our denominator is going to be. Our least common multiple of all the pieces in the bottom. I'm going to for sure need an x minus 3. Both pieces already have that, but it's still in the denominator. I need my x plus 5 that's on the left-hand piece, and I need the 5 that's in my right-hand piece. So my denominator is going to be 5 times these two pieces. So when we're looking for our parts that we multiply by, my left-hand fraction, the only piece that it's missing is the 5. So we need to multiply this one by 5 over 5. My right-hand piece, we need to multiply it by the piece that it is missing, which is my x plus 5. Over x plus 5. That's going to give me my common denominator of 5, x plus 5, x minus 3. And we're going to do these multiplications. We're going to do this distribution so that we can simplify things. So I'm going to take my 5 times my 2x and my 1. So we're going to have 10x plus 5 from my left fraction. And then we're going to subtract everybody on the right-hand side. So we're going to subtract my 7 times x and my 7 times 5. So we're going to have 7x plus 35. I'm going to give us a little bit more space here. There we go. Just so we can see where everything comes from. From here, we're going to distribute out that minus sign. So we're going to take this minus sign and distribute it through. So we're going to have our 10x plus 5 minus 7x minus 35 over our same denominator, 5x plus 5, x minus 3. And we're almost to the end of this one because we're going to simplify this. Getting our 5, x plus 5, x minus 3 on the bottom. That denominator's not changing. And we have our 10x minus 7x gives me 3x. And 5 minus 35 gives me minus 30. And then I encourage us to look at this again and see if we can simplify this even a little bit more. Is there anything I can factor out of my numerator to see if things will cancel out? A 3. I can rewrite this as 3 times x minus 10 over 5, x plus 5, x minus 3. I can't simplify anything here. Nothing cancels out. It is very, very rare that things do, but it can happen, so it's always a good idea to check. So this one was a really complicated one. This one had a lot of pieces.
I have a question.
What's up?
How did you get to 3x minus 30?
The 3x minus 30. Let me get down to it. I took my 10x and minus 7x.
Oh,
My 3x and my 5 minus 35.
nice.
Cool, cool. No, good question, DJ. Oh, and I just realized I didn't take attendance. That's okay. We've got 2 more, and that's it for today. All right, here's our next one. 3 minus 3 over 3x plus 4. And I have this one kind of late in our day because these ones throw people off. It's not any more complicated than it has been, but the fact that that first piece doesn't have a denominator just like derails trains of thought. Because what is the denominator on a whole number? 1. So my least common multiple of my denominators is just whatever the heck the right denominator is. So whole numbers don't make it harder, they make it easier, but we always get thrown off by them. So that's why I wanted to do one like that. So our least common multiple, our denominator is just going to be our 3x plus 4. So what I need to multiply the 3 by is our 3x plus 4 on the bottom and the 3x plus 4 on the top. So our numerator is going to be, I'm going to take this 3 and multiply it. We're going to have our 9x plus 12 minus 3. Does everyone see where all those pieces come from? So then let's simplify this. 3x plus 4 is my denominator, and my numerator is 9x plus 9. And again, we could simplify this a little bit. It's not going to make anything cancel out, but it's good practice for us. Because my numerator has something in it we can factor out. What can I factor out of my numerator? 9. So this is 9 times x plus 1. And my denominator is 3x plus 4. Remember, it has to be in multiplied form in order for us to be able to factor anything, or for us to be able to simplify and cross anything out. So can we simplify and cross anything out here?
No.
Nope. That's our answer. Questions on this one? Okay. We have one more, and it's going to combine together both adding and subtracting. Dun, dun, dun. So this is our last one. We've got our x squared plus y squared over x squared minus y squared. Y over x plus y minus x over x minus y. So start with writing it down. Alright, so our first thing is that we need to figure out what our least common multiple of our denominators is. Which means that I'm going to need to put this into factored form in order to find what pieces we need in our denominator. So look at that first one and see if we can factor that. To get to, oops, sorry. I'm marking our attendance because I forgot. Because it's crazy. Okay. So on this first one, how can I factor x squared plus y squared? I've got two things that are perfectly squared, and they're being subtracted. So it doesn't matter that they're both letters, because that tends to be the thing that throws us off. That's a difference of perfect squares here. We can write this as x plus y, x minus y, because this is a difference of squares. We don't need to change anything in our numerator. We're just going to leave it as it is, x squared plus y squared. So now if we look at all those denominators, trying to figure out our least common multiple of all those pieces. Well, this is a piece in here, x plus y, I've got that here. X minus y, I've got that here as well. So our least common multiple is actually that factored form right there. X plus y, x minus y. So when we're figuring out what we need to multiply by, we're going to use this factored form. So when we're coming in for our adding piece here to get it to this common denominator, it already has the x plus y. We do need to multiply it by our x minus y over x minus y. So we're going to have xy minus y squared when we do this multiplication. Then we're going to put our subtraction piece, and we're going to aim to get this to that same common denominator. I've got x minus y already here, so we need to multiply this by that x plus y, that piece we're missing. So we're going to multiply that out to get our x squared plus xy. And we've got everything to common denominators. Questions on that step because it's very xy-y. All right, now we can smash our fractions together into one big monster gargantua fraction. Yes, dear. You talking the numerator over here? It's only a difference if it's subtraction. And the numerators we don't want in factored form until the very, very end anyway, because we need to combine the like terms. So we're getting our common denominator down here, our x plus y, x minus y. And our numerator is going to be x squared plus y squared. Then we're going to bring in the middle pink one. We've got plus xy minus y squared. And we are subtracting both of these. So I'm going to distribute my minus sign through like this because I don't want to have to rewrite it another time. So we're going to have our minus x squared minus xy. such a jerk for this one, holy cow. Look through this and combine our like terms. What does this numerator simplify down to be? Because I have x squared minus x squared. So we have 0x squareds. I'm going to switch and do that with highlighter instead of with the same pink. And my x squared and my minus x squared. I've got my y squared and my minus y squared. So those cancel. Those go down to 0. I've got xy minus xy. So I have 0 xy's. So what do I have left on the top? I didn't have anything that simplified. I just had things that canceled out. I don't have anything left. It's not that there's a 1 up there. I have a 0. I have 0 things. If we cancel out fractions, that's when it's simplifying down to 1. But if we're just adding everything together and it all disappears, I've got nothing. So this whole thing just equals 0. There's a whole lot of for 0. But it was really good practice on a lot of our things, and we combined together our adding and subtracting. So the adding and subtracting looks really scary because there's lots of steps in there, but it's not the worst. We've had worse. Questions on this? Okay, so work on homework 9-2. Tomorrow we're going to be heading in what feels like an entirely different direction with this for one day, and then we'll review next week for quiz on Wednesday. Because we only have a week left till spring break. Weekend tomorrow is the last day. All right, so you guys have the rest of however long. I don't know yet because my email got caught on the screen. So you guys have, I'd say, at least 10 minutes to work on stuff, possibly longer. Use this time. Finish homework 9-1, finish homework 9-2. You can do everything on it now. Ask questions, do the thing.